Here comes the recording. Welcome, everybody. We're going to be working on the materials in Module 1. This is our first real module with content here. We did a bunch of intro stuff here tonight, so we are still in the first night of class, and we're going to try to get through some of this stuff. And whatever we don't cover here in this session tonight, we will be covering in Thursday's session, and then also working on the coding exercises by the time we get to the Thursday session. As is pretty typical with the modules that we're going to present to you, we will be providing reference materials, right? Not in the form of a textbook, right? And you guys should really applaud that. In the old days when we used to do coding courses, we would find textbooks, and some of them would be hundreds of dollars. You know, by the way, like you pay like $400 or $500 for a class, and then all of a sudden your textbook's like $300, you know, that kind of thing. This type of maneuver of eliminating the textbook is something that we've done over at my institution as well. I'm a huge fan of it. It does require a little bit more work on the faculty part to prepare the materials, but you know what? I really like this a lot better because it's a little bit more freeform, and I think we focus more on the concepts a whole lot better. It also shows you that with coding, that there is so much good information out on the internet that you can draw from to augment your learning from a lot of different sources. We've already gone through the process of choosing a integrated development environment, and the acronym, by the way, is IDE, which is the software we're using to code. And I recommended for most of you to use Visual Studio. Some of you are using Visual Studio Code, and maybe some of you will try the JetBrains Writer product. I know that if you take this class with Brittany Schultz, she loves that product a lot, you know, and it's kind of a preference thing. But my demos in the class will be focused around Visual Studio, which I do have down here in my taskbar. The materials for the unit that we are going to be going through are in this slide deck here, and you can hit the little button here and download it if you wish, or you can just watch the screen as I'm presenting it. This is in the form of a PowerPoint, and I'm going to go ahead and open that PowerPoint right now. I'm not going to start immediately on lecturing off of it, but I just want to point out the fact that the slides are available for download, so you can keep a copy of these in the aftermath of class. You know, you can come back to it and look at the materials. I do use the slideshow to kind of guide us through the materials, kind of concept by concept. Once again, our faculty have put this together here at this institution. It's really well put together and has a flow to it, and we hit the topics in a really organized fashion. The one thing that you should know about working with PowerPoint slides is you'll notice, like, I'm opening this up on my machine, and I have the PowerPoint software is installed on my machine, so I'm using PowerPoint itself to look at them. You can also open up these slides with Google Drive, right? So that allows you to open those. Microsoft Office, by the way, is available for all the students at WCTC for free as a download, and you can look at instructions and on the WCTC website for doing that. You can also use the web-based version of Microsoft Office that runs through a browser, and you can look at the PowerPoint that way. If you have difficulty opening the PowerPoint, and for example, would like me to convert it into a PDF and you can read a PDF, I can do that for you. Just let me know. But once again, this is kind of our primary material for the course, and it also structures kind of the flow of the class, if you will. When I do lecture on the PowerPoints, I don't usually go into like slide share mode where it comes full screen. I like to be able to bounce around the screen and code at the same time. And then I always like to point out to students too that PowerPoints has like a notes section down here where you can type stuff as I'm speaking. Sometimes there's notes already in there. Most of the time there's not, but you can add your own notes to the slide. It's kind of like a good way to kind of keep track of things. Like if I say something that's maybe not in the slide and you want to remember it, you can type it in. You do have to make sure the editing is enabled though for that to happen. All right, for now, I'm going to kind of put that out of the way. It looks like I already had it open before. But just be aware that each one of the modules that we have will have a PowerPoint presentation. And I don't know if you guys noticed how many slides there were in that. There's a lot of slides to go through, but I promise I won't make it boring where you're falling asleep. You know, we will be kind of coding as we're doing the PowerPoint. But there's lots of concepts to go through, and that's what the PowerPoints are about. There are some really good tutorials out there. So, the first thing I'll point out is that if you look on the Microsoft website itself, right, like right from the download page, they had like a guide to help you install, and they have all these tutorials right there that you can kind of dig into. And I will say in the old days, Microsoft did not do a very good job of that. They really didn't have a lot of reference materials like this out there, but they've really kind of turned the corner on it in the last 5-10 years. And just for example, you can go out to their website and they have guided tutorials where they walk you through step by step creating a program with explanations on how it all works. And I think this is a fantastic resource. On top of it all, you can borrow this code from here. Like you can just hit the copy button or highlight it and copy it and bring it over to Visual Studio and type it up there and check it out. And I think that's really, really helpful. The other thing that you should be aware of, right, is all these little code windows on their website have a little run button. So you can actually take the code and run it in your browser and see what it does. And right now it's loading the code up, and I think it's running it because the thing's spinning. We'll see if it actually loads up. And I'm waiting, I'm trying to do like the presentation here. It's running a little bit slow, right? I think Microsoft was affected a little bit by the outage that happened yesterday too. Yeah, that should already have loaded. But the whole point is they do have these editors here where you can look at the code, but they also have this little runtime environment. They've built some fancy little application in the background that allows you to execute the code that normally wouldn't run in a browser, by the way, right? So there's backend technology that drives this. But the tutorials are helpful. I don't usually do those here in class, but they're great auxiliary ways for you to kind of strengthen the topics. And I would strongly encourage you to take, the 5 or 10 minutes it takes to go through it and just read the material and try the little examples. So the first example is doing a hello world, and we will do that in just a few minutes. So hang tight on that. And then there's another one here that talks about how to use numbers in C#, right? So please check those out. I have this other little module 1 problem solving thing that I am going to talk about, but I want to talk about some of the C# concepts first from W3 Schools. W3 Schools is actually a very important website for coders. Just to give you a little bit of background on it, and in fact, instead of going to the links that I provided, I'm going to go to their homepage and just kind of talk a little bit about what this website is and why it's important for coders. W3 stands for World Wide Web, by the way, and this website is put together by the World Wide Web Consortium, which is the official standards issuing body for the internet and all of its approved languages. The 3 primary languages of the internet, by the way, are HTML, CSS, and JavaScript, and those appear on just about every web page out there. And they set the standards for those languages. And so web developers have known this for years, that W3 has a site called W3 Schools that provides you arguably the hands down best information, especially on those 3 technologies. So if you're learning how to code for the web, this is the go-to reference spot. What I think they discovered is so many people would come here to learn those 3 languages. They're like, well, there's other languages we use for web too. Like we use SQL for databases, and we write Python backends, and we write Java backends, and we create PHP and blah, 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 C#. Right? And I'm trying to be kind of funny about this, but they have an excellent section here on C#. And this actually is our primary reference material for the course outside of the PowerPoints. Now, one thing I always tell my students is when you're learning how to code, right, you do get very overwhelmed initially with the fact that there's so much information to absorb. And then, like when I went to school, and I always kind of use this weird analogy, like when I went to school back in the 90s to learn how to code, late 80s, early 90s, whatever, we didn't have computers in the classroom. I would go into the classroom with a notebook, and the teacher would write the code on the board in chalk. And hopefully you wrote down the right thing. And I would have to copy that And then I didn't own a computer at home. I'd have to run to the computer lab, wait for a spot to open up whenever, whatever time it was, and then sit down at the machine and do my coding and figure out if I got it right or not. Right. And hopefully I wrote it down correctly. Can you imagine like all the issues there? We don't have to fight through that. The other thing is we would learn all these techniques and we really didn't have a reference aside from our textbook. So if the textbook was written well, we had a reference to, oh, okay, well, this is what this does. You know, you could look it up in the book. Here's what you discover very quickly. You cannot remember all this stuff. So what I'm going to ask you to do is don't pressure yourself to think you have to memorize this. Because here's what's going to happen. You're not going to. What you should memorize is where to go on the internet to find the information when you need it. There are things that you will retain in your memory, but things also change over time. So to me, it's really important for you guys to latch onto that fact that you don't have to memorize it. And there are excellent reference sites. And this is probably the best reference site on the internet, hands down. Right. And I've explored a whole bunch of them. It's not that there's not other valuable sites, but this one is very well structured. They have a lot of resources here. Everything is well vetted. It's updated constantly. When a language evolves, they add the new features. And if you scroll across this bar here at the top, I just want you to notice all the different languages and things that you can learn, things you've probably never even heard of, right? You notice how it just keeps going. It goes on and on and on. So great site to go to for just about any programming language of note that's out there where you want to learn it and improve your skills, right? And then if you're working in that environment and you want to like, how do I, or what thing do I use to do this or that? Here's your site, you know, so bookmark this one, highlight it, double bookmark it, whatever you have to do. You know, this is the site, folks. All right. Let's talk about C#. C# is a language, and we talked about this a little bit earlier, that was developed by Microsoft based on the original C language. C# is the language that Microsoft uses to develop its operating systems. And I think that, I'm not sure when they switched over to it completely. It was either during XP or maybe Windows Vista era, they switched completely over, somewhere in that time range. Since that, you know, if you guys are curious, before then they used to use Visual Basic as their operating system language, and prior to that it was BASIC to do all the DOS operating systems. C# is what we call a compiled language. What that means is we will write computer code. That code, which is sort of English-like, gets converted into what we call machine code. It gets fed into a compiler and debugger. It looks at the code, and if the code is accurate, it converts it from like words and letters and symbols to binary information that your computer system can understand and process, but you as a human arguably cannot, right? But computers ultimately work on electronic pulses of positive and negative voltages. We call it binary, like it's ones and zeros, but it's really positive and negative voltages inside the machine that do everything. The machines only understand that type of binary information. And when we write a C# program and compile it, it turns into an executable file that then can be picked up, transported to any Windows or, you know, Windows-based machine and execute in that environment. Since the .NET 6 libraries were developed, right now I think the libraries are up to version 9, and we'll talk about that in a second too. The .NET platform is now cross-platform, meaning I can run .NET on a Macintosh and I can run it on a Windows machine. Prior to the .NET 6 libraries, that was not possible, right? So there is some cross-platform ability on this, but generally .NET is designed for the Windows platform. Not to get overly technical about this, but when you create a program in C#, that gets converted into this machine code, basically, that runs through what we call the common language runtime libraries. We'll learn about this in the PowerPoint, which just about every program that runs on Windows has to go through those libraries in order to operate on the operating system. It is somewhat virtualized, not quite like Java is, but it runs in that same kind of realm. And what that means is it's not truly running native on the operating system. It's running inside a containerized environment within the operating system. And it's one of the reasons why our modern operating systems are a lot more stable than they used to be. For any of you that have coded Python before, and like, for example, Caleb was in my Python class this past spring. Python is a very different type of language than C#. Python is what we call an interpreted language, meaning we give it a set of instructions and it simply executes those instructions. It never turns into, Python code never turns into an executable file or a binary. It's always just a set of instructions. It's kind of interesting, especially in light of the fact that most data analytics and AI work is done with Python, strangely enough. C# though is a compiled language. So ultimately you are creating an executable file, right? That can, as I said, will run on any Windows systems. What can you use it for? Well, as it says here, you can make web application, desktop apps, mobile apps, games, and much more. And it's used for a lot of different things. A real basic example of what a C# program looks like. Now, when we will be coding, and I'm just going to give you guys a heads up, there's kind of two modes you can code in. One is where you see all the nitty gritty of the program. As we see here on the screen, there technically is a namespace, a program class, and then a main method, and then we start writing code, right? So like we have all these containers that we're operating within as we're writing the code. The mode that I'm going to advise you to code in as we start is to basically obscure all this stuff, you know, that I just highlighted, right? All the stuff up top and all the stuff down below, and we'll just be writing code inside the main method, which we won't even be aware of, right? And this is a good place to start because it avoids some of the structural issues that you run into otherwise. When we create a new program, and you know what, I'm going to just go ahead and do that right now. So if you guys do have Visual Studio functional, you could follow along with me a little bit, but I will repeat these steps, so don't panic if it's not ready yet. And plus I'm recording it in a video, so you can always come back to it. So when you launch Visual Studio, that you'll get this interface that pops up. With mine, you can see that I do have a bunch of stuff here that I've already coded, but you get this interface and you get these 4 basic options here. The one that we're going to choose most often when we build a new program is the bottom option, which is create a new project. It is also possible to like kind of avoid all these selections and just go right into the interface. But for right now, please follow with me and click on this. So we would create a new project, and that'll bring us to this window that appears. And what I'm going to do is I'm going to reset my window because right now it's already filtered, right? And they have these 3 filters at the top where you can choose your language that you're working with, the platform you're delivering to, and the type of project you're creating. All right. So because we're in an intro level class, I'm going to have you make these selections, and then you're pretty much not going to change them for the semester. But when you get to other classes, you will have the capability to select anything depending on what you want to build. And when you start digging in here, you go, what languages do I have available? These are the ones I have available already. There's like 10 programming languages straight up in here, right? But we're going to be working in C#. So go ahead and select C#. For the platforms, we are coding for Windows. Okay, well, if you're on the Mac, this isn't going to be an issue, but I think my one Mac person here is using Visual Studio Code, so not an issue for you. All right, so I'm going to select Windows, and then the project type that we're going to work with to start with is console, which means we're writing for the command line. But if you want, you can look at this list and look at all the different stuff that you can build. It's like, oh my God, right? There's like a whole bunch of stuff in here. But our goal right now is console. If you wanted to build a desktop application that had a graphical user interface, you would choose desktop, right? And then you would have graphical tools to draw from, right? But console is our selection. And then as we do that, notice how our list of possible projects is now narrowed down significantly. We're going to just choose console app. So make sure that's highlighted, and then go ahead and click next. All right. You will get to this screen where you're asked to name your project. And for right now, I'm not really too worried about what I'm going to name it because I'm just kind of doing a demo. But usually you want to name it something that makes sense, right? Like, so if I'm coding, let's say, a mortgage calculator, it might be appropriate to call it mortgage calculator, or if I was coding I don't know, tic-tac-toe game, maybe I should call it tic-tac-toe, something that makes sense to the project. I want you to take careful note of where it's storing your files, where it chooses to store your files natively is not where you would assume it would go. This is not a folder that normal humans traverse. Once again, this is in the users folder, my user account, the source folder, and repos, right? And repos, by the way, stands for repository. That might not be where you would intuitively look to find your stuff. So if you don't like that location, you do not have to put it there. And in fact, what I would advise, at least as you're getting started, is to maybe go to your documents folder, maybe create a folder for like wctc, and then maybe for your intro to C# class, and then module 1, you create folders and put it in a logical spot so you can find it easily. And this is one of those things that, I do sometimes coach on this, like where should you store your files? And I think that, this is what I've been doing, right? And I've been creating a folder inside my documents folder called wctc. I have a folder for intro to programming, and then I create a folder for each semester that I've been teaching at least on this machine. So I'm going to go ahead and create a new folder for myself, and I'm labeling it 2025 fall because that's what makes sense to me. You should label it what it is so that when you look at it later, it's not called like new folder, what's in there, that kind of thing. Organizing your files, to me, is one of the most fundamental IT skills you can have. Remember, normal humans don't have to know where their files are, but IT people should always know where their files are. All right. I'm going to go ahead and go into that folder and then click select folder. And then when I go in there later, I will notice I'll have a different folder named whatever I name my project. And maybe I should just call it, I don't know, like test project 1. Now you'll notice as I'm naming this, I have a convention. I usually don't put spaces in my file names. This is kind of like a old habit of mine. You can put spaces in your file names. I also tend to name things all lowercase. That's just my convention, right? You name things as you see fit. It is pretty common for a lot of programmers to camel case their stuff, which means you start with lowercase letters, and then when you get to the next logical word, you start with a capital letter. So some people will name it like that, and these are very subjective choices, by the way. And there's no rules. It's what you're comfortable with. All right. A couple of boxes are checked here. And I want you to notice there's this box that says place solution and project in the same directory, which I do recommend for small little programs like the ones we're going to write in this class. If you were writing a program that's really a collection of programs, I would uncheck that box. This is not one of those situations. What a solution is relative to a C# program is it's basically a pointer file that describes where all the resources for this software that you're creating are located within this folder structure. Usually it's placed in the root of the project. Since we're not creating multiple programs, we're going to create just one simple little program. Putting it in the same folder is logical. Otherwise, it goes one folder level above. All right, I'm going to click next. From here, we get to this screen that basically describes what version of the libraries that we're using to create the code. And then this little checkbox here, which for now we are going to uncheck, and I'm going to demonstrate later what it does when you check it. Depending on when you install the product, you are going to have different .NET libraries available on this list. At a minimum, you need to be using .NET 6. And I want you to notice .NET 6 is now out of support. And just to do a little bit of explanation about version numbers, at least with .NET, the way that they work it is the even numbered versions are what we call long-term support, meaning they plan those to run for a long time and they're going to update them and do security fixes and things like that. The ones that are standard term support are kind of like the test version of the next even numbered version. So .NET 9 is like the test version for 10. It works, you can deploy in it, but really it's a precursor to 10. And then 10 will be a long-term support version that will be out there for a long time. What I would recommend right now, I don't know which ones you have available on your system, but I would do .NET 8. That's what I'm going to use. That's the one that's current, active, and in long-term support mode. Does anybody have any versions different than this in theirs? Does anybody have a version higher? I would doubt it. Okay,
I just have .NET 8 and .NET 9.
okay. And if you did
Yeah,
the
same
install
here.
today, that makes complete sense. That's the logical versions that you should have. I installed mine previous, like years ago. So like I still have those old versions here and I could code for them if needed. So we'll leave it at .NET 8 and leave all the boxes unchecked, especially this one that says do not use top level statements, and then go ahead and hit create. Now for anybody using Visual Studio Code, I'll do a quick little demo on that. But I want to show you here as we get into the product that we are already missing those what we call the top level statements, the ones that we were seeing on the website here, which is basically all of this stuff here is obscured from our view. It is still there, right? These are just containers that hold code. And depending on the complexity of the program that we're writing, sometimes we want them there. But when we're doing simple programs like what we're doing, they do get a little bit obtrusive, which is why I ask you to kind of omit them. As you get into the program, they pre-create your first write line command. And I want you to notice the syntax for this, right? This is, the most basic and fundamental of all programming commands in any language, right? Like you're obliged when you first learn how to program is to write a program that puts hello world on the screen, right? And the code is already pre-written for you. But I want you to notice the syntax of it, right? So we have console, which tells it we're writing to the command line. The write line is a function, which takes whatever inside the parentheses and puts it to the screen. Notice at the end of the statement, we have a semicolon. And I'm going to zoom in a little bit so you can see that a little bit better. The line at the very top is a comment. And we know this because it starts with 2 double forward slashes, meaning this code, anything that follows that double slash on this line is functionally ignored. It's not going to be executing code. It's just information, right? And what they're doing here is they're giving you a link where you can like read up on the template that you're using. And really functionally, we don't need that. If you want to keep the comment there, you can put, your name up here if you want, maybe the name of the program, really, you can kind of put whatever you want up here. Right? It's non-executing. I used to require my students to put their names in their code. I really kind of don't do that anymore because we use learning management systems. But let's have some fun. If you guys have this up on your screen like I do right now, you can go ahead and up here in the toolbar, you notice how there's a green play button. It kind of does what you think it does. When I hit that button, here's what will happen. Your file will be parsed by the debugger, meaning it'll read through your code. It'll look for errors. Provided there's no errors in your code, it will turn it into machine code through the process called compiling. And then it will execute that code and load a window at the bottom of the screen that will show your console output. So let's go ahead and run it. And you'll notice I do have an output window here at the bottom, and it's taking a moment to launch. So it's doing some stuff in the background. And notice it did it. It put it into a command prompt window. There's the result of my program. And then it gives me a message, right? It shows me what it ran and that the program's over. but there's all the excitement right there, folks. Right? Yay, we got a program to run. Right. As the window says, you can press any key to terminate it. And then if you come back here, you'll notice like right now I'm typing on the screen. And as I type, if you look right up here at the tip of my mouse, see that right up here? There's a little asterisk on the tab for the program that indicates the program is not currently saved. I can save the program by just going to the file menu, choosing save, or hitting the little save diskette here in the toolbar. But notice when I hit the run button, the program saves first, then it compiles, then it runs. And then, of course, you can terminate it from running. The output window that you see down here, this is what we call the internal console for Visual Studio. So like as stuff is running and processing, or if there's error messages or something like that, that output will be shown down here at the bottom. It's kind of looking at the back end of what's happening in the engine of the coding machine that's running all of this. And sometimes, especially when you have errors, this area is very, very useful. The general anatomy of the screen is pretty simplistic. We have our primary coding window here, right? There we type all of our code. We have what we call the Solution Explorer here in the sidebar, which sort of looks like a file and folder thing, but it's not really. What we're really looking at is the structure of the program with its components. Sometimes there are folders in here and files, but sometimes it's components of files as well. Right. Down here in the bottom right corner is a properties window. So like, especially when you're working with, I would say GUI programs or graphical programs, you see like little fields and form values here that you can tweak and control, right? Usually not very pertinent for the work that we're doing here. This is a super brief overview of the product, and you will get much more comfortable with it as you go. A couple things you will notice as you're coding. Notice that as we code, this window is basically a plain text editor, that there are line numbers that are generated. These are very helpful, especially when you get an error message and it says error on line 5, right? And then normally, like if the code is broken, and I'm just going to break my code by removing a little thing here, this is what happens. It starts to underline automatically. And then as you hover, it'll try to give you a suggestion to fix it. We'll talk about how those tools work. And there are some tools here, and what it's suggesting is totally wrong, by the way. But sometimes it does make suggestions that are spot on. Nick, I see you have your hand up. Your question, sir.
Yeah, my code doesn't have like a run button like yours does.
Okay.
Here, do you want me to share my screen?
Yeah, give me a second, and I'll circle back to that, because that's a situation that we have to kind of deal with.
Okay.
Are you're on a regular Windows machine?
Yeah.
Are you administrator on the machine?
No, I'm not.
Okay. Is this a school machine that you're using?
No, it's just like a family computer.
Okay. So you are allowed to install software on it?
Yeah.
Okay. Let's hang tight with that, and we'll circle back to it
Okay.
if you're okay with that, because there is a special way to fix that. I have to try to remember what the fix is, so I'll look that up when we take a break. If we take one, I guess, because we're running out of time. For those of you working in Visual Studio Code, I'll bring up this environment here. And I do have a bunch of stuff open that I want to kind of get out of the way here. When you're in Visual Studio Code, you will launch into the product in kind of like a welcome screen. Normally, what I recommend here is that one of your first tasks is to create a folder to put your work, right? So kind of like I did inside of Visual Studio, we're gonna here open folder. So if you already have a folder created, that's great. If you don't, you can create one. And what I'm going to do is I'm going to just use the folder I already have created. And then I'll put my work inside this folder. When I select a folder to work in, and this seems kind of like a weird way, why are you doing this first? Why aren't you just writing code? Because the folder or the file management part of it is actually pretty critical, like knowing where your stuff goes. It also creates what we call a workspace. And that way we can toggle that workspace here. I do want you to notice that when we were using the full blown product, that the solution explorer is on the right, and Visual Studio Code, all those little panels are on the left. And one of the first ones that you should learn how to use is this one, which is just to be able to look at your project. If you've attached to a folder, you can see all the stuff inside your folder here, including the program that I just built, this one, over in Visual Studio. Now, if I wanted to create a brand new program inside this environment, I would just very simply, and I should expand that, hit this little button here to create a new file, or I can do it from the file menu up above, and then you just give it a name. So like I can call it hello.cs. So all of the programs that we create here will have a .cs extension, which stands for C#, right? And it tells the compiler that it's C# code. Now, one of the things, the active document is not part of the workspace. Not all language features will be aware. Okay. I'm going to dismiss that for now. But once we get inside here, we can start to write some of the same commands that we had before. For example, and notice that there's this feature what we call IntelliSense or autocomplete. And I'm kind of letting it guide me. I don't know if you guys are picking up on the fact I'm typing like the opening parentheses and it's typing the closing one. I'm typing the opening quote and it's typing in the closing quote. And then I'm just going to type, hello, Milwaukee, or something like that. At the end of the line, I do want a semicolon to terminate the statement. And then once you have it in this state, provided that my environment is set up correctly, yeah, so it's not letting me run it. So my compiler's not working correctly here. But if you have the C# tools built in here, this should run. And Megan, you're the one that's being affected by this. So right now I'm not ready to run mine. Is yours running?
No, it is not.
Okay. So we'll have to work on that problem separately. Nash, I see you have your hand up.
Yeah, I give a build failure. Is that the
Which is
same?
what I got.
Yeah.
Yeah, that's what I got too.
So that, I mean, it's not good, but that's normal for now.
It's normal when you're not set up correctly.
Good.
Basically. And I'm not set up correctly. I've been doing a lot of Python coding in this environment lately, and database work, and it's all configured for that. Normally, I think my extensions should kick in. And I'm looking at the error messages right now. Okay. You know what? Let's not worry about this for the moment. What I'll do is when the session ends, which is going to be in a few minutes, we'll just actively work on it without the recorder running and fix it. And then when we get back next time, we'll figure out what tools we need and what we need to do to make it work. But I assure you, the stuff does run in this environment. I just think that I just don't have it configured correctly with the extensions. Because I do have C# installed, but it might not be attached to this environment. And it could be because of the top level statements are missing, which might be required here to make it run. So I'm going to have to figure out those pieces because it's been a while since I've coded C# in here. All right. We'll come back to that, by the way. I do wonder, like, for example, here's one way to test it. I could just put all that code in there, which it's not complaining about. Let's see if this runs. If this runs, then it's because of the top level statements. Okay. So I have to figure out the problem. And right now is not the time during the recording to do it. All right. So here's where we're at. We're pretty much out of time. For next time, what I would like you guys to do is make sure you download the PowerPoint. You can kind of read through that a little bit if you wish. I am going to hit all of these links next time. We'll make sure that all of our environments are working. And as I go through all the lecture topics, we will play with the code and get it all to run. And then from there, we will get into the first lab assignment and then the assignment itself. Right. Often with the assignment, sometimes we run out of time at the end of class and we'll start working on it and maybe we'll finish it in the next class session when we start looking at the solution. We'll see how that goes. I think we should have enough time to maybe get to it on Thursday. All right, I'm going to stop the recording here. We'll call it officially a class with one less than a minute to spare here. And then I'm going to hang out for a bit and let's see if we can figure out the Visual Studio Code problem at the very least. All right, so this video ends here.